Do you remember when Cooper, the protagonist of Interstellar, says time is relative, it can stretch and it can squeeze, but it can't run backwards? It's a line that not only captures the essence of the movie, but also perfectly encapsulates a rather complex scientific theory proposed by Einstein, the theory of relativity. One of the key aspects of this theory is the concept of time dilation, a phenomenon that is as intriguing as it is baffling. Time dilation, in layman's terms, is the idea that time doesn't tick the same way everywhere in the universe. Sounds confusing, right? Well, let's delve a little deeper. Imagine you're on a spaceship, hurtling through space at near light speeds. Back on Earth, people are living their lives, going about their daily routines. But here's where it gets interesting. For you on the spaceship, only a few years might pass. But back on Earth, decades or even centuries could have gone by. This isn't some science fiction trope, but a real-life consequence of the theory of relativity. Now let's take a moment to consider gravity. Just like speed, gravity can also affect the passage of time. The more the gravity, the slower the time. This is vividly portrayed in Interstellar during the water planet scene. For every hour spent on the water planet, 7 years pass outside its gravitational pull. An hour there isn't just an hour for someone elsewhere in the universe, it's 7 whole years. This is the nature of time, as per Einstein's theory. It's not a constant, unchanging entity, but rather a flexible concept that stretches and squeezes depending on your speed and the gravitational force acting on you. So, the next time you find yourself running late, remember it's not you, it's the universe playing with the concept of time. And who knows, maybe one day we'll be able to harness this power to our advantage. So, just like in Interstellar, time is indeed a fickle companion that changes its pace depending on where you are and how fast you're going. Another profound statement from Interstellar comes from Dr. Brand, who says love is the one thing we're capable of perceiving that transcends dimensions of time and space. Now let's delve into this intriguing concept. In the world of Interstellar, gravity is depicted as a force that can cross dimensions. It's a concept that's as fascinating as it is perplexing. But how does this work? Well, let's try to simplify it. Imagine gravity as an invisible bridge, connecting points in space that would otherwise seem light years apart. This is the essence of wormholes and black holes. These cosmic phenomena are essentially shortcuts through the fabric of spacetime, potentially allowing us to leap across vast distances or even through time itself. But what does this have to do with love, you might wonder? Well, in Interstellar, love is depicted as a force akin to gravity, capable of reaching across the vast expanse of space and time. It's a force that connects people, no matter how far apart they are, just like gravity connects celestial bodies across the cosmos. In a sense, love is the wormhole of human connections, allowing us to feel close to someone, regardless of the physical distance or the passage of time. Just as a black hole's gravity can pull in everything around it, love can draw us towards those we care about, often in ways that defy logic or reason. But here's where things get truly fascinating. In the movie, we're led to believe that love, like gravity, can even transcend dimensions. It's a notion that challenges our understanding of both emotion and physics. Could our feelings really have such a profound impact on the universe? Could they truly bend the fabric of reality? It's an intriguing idea, one that Interstellar explores in a captivating way. And while it's wrapped in the language of science fiction, it's rooted in real scientific theories that continue to push the boundaries of our understanding. So, while we may not fully understand the mysteries of black holes and love, both seem to possess the power to transcend our normal understanding of the universe. Remember the Tesseract scene in Interstellar where Cooper communicates with his daughter in the past? That's where our journey into the fifth dimension begins. Imagine a Tesseract. It's a four-dimensional analog of a cube. A cube has 6 square faces, while a Tesseract has 8 cubical cells. But don't get lost in the geometry just yet. The Tesseract in Interstellar isn't a literal geometric Tesseract, but a representation of a fifth dimension. Now you might be wondering, what is this fifth dimension? We live in a universe with 3 spatial dimensions: length, width, and height, and 1 temporal dimension, time. The fifth dimension, as proposed by some theoretical physicists, could be a dimension beyond our usual understanding of space and time. In simpler terms, think of the fifth dimension as a way to perceive all points in time simultaneously. It's like watching a movie where you can see the beginning, middle, and end all at once. It's a concept that's hard to wrap our 3-dimensional brains around. But that's the beauty of theoretical physics. It pushes the boundaries of our understanding. Now let's relate this back to Interstellar. The Tesseract scene is the movie's way of visualizing the fifth dimension. Cooper, in the Tesseract, perceives his daughter's entire life timeline at once. He interacts with specific moments in her past by manipulating gravity, leading to the events that set him on the journey in the first place. It's a mind-bending, time-looping, paradoxical sequence that beautifully illustrates the concept of a fifth dimension. Is this all purely theoretical? Yes, absolutely. There's no scientific consensus on the existence of a fifth dimension, let alone the ability to interact with it. But it's a fascinating concept, isn't it? The idea that there might be more to the universe than our limited perception can grasp is a reminder of the vastness and wonder of the cosmos. While the idea of a fifth dimension is purely theoretical at this point, it's fascinating to think about the possibilities it could hold. Interstellar is not just a science fiction movie, it's a movie that's deeply rooted in scientific theories. Indeed, the creators of this cinematic masterpiece went to great lengths to ensure the film's scientific accuracy, seeking the guidance of renowned physicist Kip Thorne. Thorne, a Nobel laureate and one of the world's leading experts in the field of theoretical physics, played a pivotal role in shaping the scientific backbone of the movie. From the outset, Thorne worked closely with the film's director, Christopher Nolan, and his team, providing them with detailed insights into the complex world of theoretical physics. His input was invaluable in creating a movie that not only captivated audiences with its gripping storyline and stunning visuals, but one that also stayed true to the principles of science. A striking testament to this collaboration is the movie's depiction of wormholes and black holes. These are not just fanciful elements conjured up by the creative minds behind the film. Instead, they are based on actual scientific equations and data, painstakingly calculated and modeled. In the movie, wormholes are portals connecting two distant points in space, allowing for faster-than-light travel. This concept, while still theoretical, is rooted in Einstein's theory of general relativity. Thorne provided the team with the mathematical equations necessary to visualize a wormhole, a feat never before attempted in a mainstream film. Similarly, the black hole, Gargantua, is not just a plot device but a visual representation of what a black hole might actually look like. To depict Gargantua, Thorne and the visual effects team used Einstein's field equations, resulting in a scientifically accurate portrayal that was so groundbreaking, it even led to a scientific paper being published. So, Interstellar is more than a journey across the stars. It's a journey into the heart of science, a testament to the power of collaboration between art and science. So while Interstellar is a work of fiction, its roots are very much planted in the soil of real-world science. So, what can Interstellar teach us about science and the universe? In our journey through the cosmos via the cinematic lens of Interstellar, we've grappled with some of the most profound scientific concepts that define our reality. Let's take a moment to reflect on this voyage. We began with the nature of time, a concept that is as elusive as it is fundamental. Interstellar uses the theory of time dilation to weave a narrative that transcends the linear perception of time we're accustomed to. The movie shows us that time is not a constant, but a variable that can be influenced by gravity and speed. This is not mere science fiction, but a reality predicted by Einstein's theory of relativity, one that has been verified by numerous experiments. Next, we delved into the force that keeps our feet on the ground and our planets in orbit: gravity. Interstellar presents gravity not as a mundane force, but as a powerful agent of change, capable of bending time and space. The movie also explores the concept of love as a force akin to gravity, suggesting that both have the power to transcend dimensions and connect beings across the vastness of space. And then, there's the mind-bending concept of the fifth dimension. Interstellar dares to visualize this abstract concept, showing us a world where time is just another spatial dimension that can be navigated. This may seem far-fetched, but it's an idea that is being actively explored in the field of theoretical physics. Interstellar uses these scientific theories to tell a story about love, time, and the vastness of the universe. It reminds us that our understanding of the universe is still in its infancy, and that there are mysteries waiting to be unraveled. Interstellar gives us a glimpse into the fascinating and often mind-bending world of theoretical physics, reminding us that the universe is far more complex and beautiful than we could possibly imagine.